Hey, Rani here. Shall we make a game? Yeah, so last time we were starting to read the kind of like WebAssembly module and pull out all the information that we need to be able to run the game. So we're going to continue that today. I'm thinking a bit about validation. A lot of these wouldn't actually be errors, they just become like warnings. It's kind of like, what are you trying to do? So where do we get to? We got to video columns, which is... Wait, do we actually have video columns? Oh yeah, we do. Yeah, there we go. So we're down to here. Okay. That's going to be the listener. Okay, this is going to be a 3-axis float thing. So we'll do... I'm just going to go look at what we called it in the source code, in the WebAssembly module, because at least that way it's consistent with something. I didn't name them in the protocol doc because, well, naming conventions are going to differ from platform to platform, aren't they? So it's called listener location. And we're also going to have the listener normal. And then scroll down a bit. And let's just double check here, the location is 37, get it. And it's going to be 12 because it's going to be 3-axis, it's going to be float 32, so that. What did I call it again? I called it a listener location. And we're also going to have listener normal, so it's the exact same thing, at least as far as logic's concerned. Okay, and we should probably have some validation on that actually. Yeah. Well, there's a lot of things to check, isn't it? So we're going to export those as well, or just so we can see them. And then after this, we're going to have all these, the kind of like the strict validation, the kind of just like a warning validation, and then we're going to have it with a flag saying whether the game has video, whether it has audio, whatever, and we carry it on from there. So next up we have the controllers. Ensure state quantity consistent with controller y quantity and the x, and also x with y because you might be missing the states, and the error. Okay, what we have left is, let's go to controllers, see what we name them over there. We have controller states, controller y-axis, controller z-axis, sorry, x-axis. And the clocks go back tomorrow. That's not going to be confusing at all. Okay, next up, let's just write the logic to actually pull this out of the module. It should be nice and easy. So first of all, it's the controller states. swap these around. Do the same with this one as well. Just so we've got kind of like the, we're not inverting it effectively. Oh, I need to rename this as well. Controller states, size incorrect. Okay, that's good. Okay, and then we just got the error left, and the error should just be a, oh wait, that should be, that should be an int32 array. And then the controller, so the error should just be a single int32. So just grab one of those, that'll do, that'll be the same. And just double check, it ends in a 42, yep, so we haven't missed any or doubled any up, or skipped over any, or if we have, they cancelled out. Next up, we just need to define that those exist. And what do we have here? We have controller states, it's null, control y-axes, control x-axes, and the error. Okay, there we go. So let's just give it a quick build and see what it does. Okay, we've got things out of it that look vaguely correct. I'm happy with that. Next up, let's do this additional validation. So we can get rid of all this console logging stuff now. We don't need this anymore. So if, and we check that the video buffer is there. Hang on, if the video buffer isn't null, and number of the maximum video rows is null, then we've got an issue. That's going to be an actual error, isn't it? Because like you specify one thing, but not enough to actually use it. Cannot. Maybe that's actually a warning, and I just clear them both. And then if we've got the other way around, do the same thing again. So like, well, we can't use the maximum number of rows because we don't have a video buffer. Okay, that's good. And next up, we need to check that the sorry, the size of the video buffer matches up with the number of rows that we just received. So it's the video buffer isn't null. This is kind of the advantage of doing this like nulling up front. It means we don't have to sort of cross-check validation later. We can do it up front. Okay. So I think there's like a length in here. Yeah, there is. Okay, so in that case, we have to throw an error because you've given us two things that are completely contradictory. I said, what type is this? It's a float 32 array. What? That's wrong. That's completely wrong. Just give me a second. I'm just going to check what it was in the previous one. Yeah, index.html. That's what we're after. Video buffer colors. It was one of those. Okay. Actually, maybe colors is a better name than buffer because they're all buffers. And it should be that. Okay. Yeah, I'm going to rename it from video buffer to colors. I came up with a better name for that last time. And we can do the same for this. We can do audio samples. Yeah, I like that a lot. That's just much cleaner. And we're going to have to change a bit in here because we're exporting it here, and it's going to be like, huh, where's it gone? And then we can rename it here, video colors. And then we should have the audio output. I think that's way at the top, isn't it? Here it is. Okay, good. Video colors is video colors. How do I phrase this without sounding weird? Video colors, length of video colors not evenly divisible by the maximum number of video rows. That'll do. Okay, so next up we need to check if there's a safe area or not. I think here is that you might actually legitimately have games that have audio only. I know this is kind of weird, but it's definitely possible. I'm also thinking you might actually only have, say, the safe area width or the safe area height, because you might have, yeah, and it should just default the other one to being the full size of the viewport. Yeah, I'll do that. And we can actually calculate the height, the width of the viewport here actually. Oh, console. No. Okay, and then here, if the safe area rows is null, then we need to fill it in with the, sorry, the maximum video rows. Okay, that means we don't need any logic further down, sort of checking whether that exists or not. We can now do the same columns. Oh yeah, we also need to check whether that's actually been passed in, otherwise we're going to be assigning it back to null. You know what? That'd actually be fine. That's actually going to do nothing if yeah, if that's null, we don't actually need to check because we're already it's just going to assign it back to null. Okay, oh yeah, the next thing we need to do is we need to check that it fits within the buffer. Okay, sorry, that's good. Next up we have, right, yeah, we have tick rate stuff. Very similar to this logic. So if the tick rate, hang on, is it ticks per second? Yeah, there we go. And tick progress is null. If we have a tick progress, but we don't have a ticks per second, well, it means nothing, doesn't it? So we need to recess it. Unable to use tick progress without ticks per second. Able to use audio samples. Continue filling all these out. Video, what's this called? Rows. Oh, helps if you spell it. Helps if you spell it right, doesn't it? Oops. Okay, so really dealing with that. Yep. Okay, good. Good. Okay, next up, we need to start pulling out some events actually. So at the moment, when you there's like a function up here that retrieves a function export from the WebAssembly module. We need to give that a bit of a tweak so we can do an optional export because at the moment we don't really have anything like that. And so if I put this here, optional export. Oh, you know what I could make this do? Actually, I could do this. I could reuse this in here. That way we don't have that big, chunky, horrible looking hazard property call more than once. Ah, it doesn't like the name export. We'll just got exported, that'll do. And then we can do something very similar down here with this. We can get optional function. Ah, that does mean this will never be used. Oh, it is going to be used there. Okay, that's fine. I was like, if the required function thing is always going to be calling the optional function thing, and then just null checking the response, that means that this will never get called. But that's fine, because that is actually still used there. Okay, is it happy with that? Looks like it's happy with that. So let's grab out our exports now. I should probably do them kind of here, or maybe up here. We're doing all the kind of like, you know, pulling out of things up here. Yeah, let's do it all in one place. So what have we called them? We called them tick, audio, and video. Okay. Those are going to be lets because we're going to be removing them if things are missing that are needed. Yeah, so we can't call into the ticks per second, the tick event if we don't know how many it wants per second. That's fine. We can actually, hang on a second, we can actually, even if we don't have an event to call, we can still like generate audio, I think. Well, that said that wouldn't be necessarily correct, but we'll stick with that. It's a lot of validation, isn't it? It's a lot more I did on like the previous version of this. I mean, when you're sort of building something so someone else can use it, I guess you have to really go in sort of deep with the validation. Yeah, that's the only place it's used. That's good. Okay, what do we have next? Audio events. Hopefully that one's nice and self-explanatory. Can't use audio samples for audio. And we're going to have the converse as well. So that we can't use the audio samples, so the audio event if we don't have any samples, because what would the point even be? Okay, that's nice and simple. That's done. Next one we need to check that the pointer state buffers exist. So if now there is actually a valid case I can think of where you'd have the pointer state but no like X and Y coordinates, and the reason for that is it might just be a game we can click anywhere. I think it's pretty unlikely, but it's not super likely. But pointer row pointer state, no point in that at all. And the reason for that is, well, I mean, the pointer row and column are only valid in certain pointer states. So if you can't look at the state, you don't know whether they're valid to read. And the next thing is, if there's no video output, well, then they can't, you know, hang on. we could still track if they're clicking somewhere. It's just that without like a video buffer to kind of map the pointer movement to, we don't know where they're actually pointing. But we can still tell. We can still tell if they're clicking. Okay, that's good. Okay, all right, we're almost there. Look at all this validation, man. I might have to start breaking this up into separate files because this is getting a bit silly. This is a lot to have in a single file. Bear in mind, we haven't actually put the video and audio handling code in yet. You know, I wrote this down earlier and I'm actually going to drop it. It's kind of fine to just have the listen location, no normal. Be a bit weird, but it's fine, I guess. So we have a listener location and we have no audio samples. Then you can't have that. Can't have here's where I'm listening to you from. Oh, but where do I put the sound? Don't know. Thinking about it, I'm never going to use the listener location from here because this isn't like a VR setup, so it's just going to be the normal. I can actually get rid of the bit that I can actually get rid of this entirely. I don't need that at all. We're never going to change it from this end or read it, so we can get rid of it. Yeah, just get rid of that. Okay, that's good. Next up, we need the hang on, control the state quantity. Yes. Okay, if the controller states on, let's first of all check that they exist correctly, so that we've got we've only got to say that these sticks if we have states. Because again, kind of like the pointer, it'd be kind of wrong to read from the analog stick position if you haven't checked that there actually is a controller. Man, I bet there's tons of bugs just lurking in this somewhere. Okay, so then we've got our last couple of, we've got our consistency checks. Okay, so if the control states isn't null, and actually let's just check for controller y-axis, and the reason for that is, it won't be there if there's no states. Inconsistent. I guess in theory I could actually cap it to whichever one's smallest, but I'm not going to do that. Okay, that's a lot of validation, isn't it? Oops. Oh, I didn't mean to do that. Oh, I only meant to run it again. I didn't mean to. What happened there? That looked like it lost all the history. That was strange. That was really weird, wasn't it? Okay, let's run that and make sure we don't trip any of the validation. Come on. Faster, please. I think that worked because we removed all the console logging. It didn't crash, so that's probably good. That's probably good. Damn, I've made a lot of changes to this already. Stop reading buffers, and then I'm just going to check all this and make sure this is all good. Buffers, not great naming, whatever. Yeah, still got the Blender toolkit in development. I'm going to get that done so when I start doing week, that might seem like a bit of a weird thing to focus on given the rest of the engine isn't there. But having that in place means that when I start sort of streaming 3D modeling and texturing exclusively at the weekends, I've got the toolkit ready to go there. Right, what's next? I'm just going to speed up the build a bit because at the moment it's doing like a zip step and we're not really using that. So we can just cut that out. That should be good. Okay, so now we've got all of our inputs ready to go. And I'll tell you what I'm going to do. I'm going to flip back to the previous project and I'm going to grab that code that initializes state buffers. There it is. That's the one. Some of this isn't going to be 100% transferable, but most of it is. Actually, it's not that bit we're going to be using. It's going to be this bit. Okay, so this bit here, I think I renamed this. I think I renamed this to like local hyphen storage. Yes, I did. This bit basically delves into the browser's kind of like, data store and pulls out a chunk of information regarding the state buffers. So I actually want to store those. And then I'm going to use it when I'm looping over the buffers down here. This could come back null. Yeah, if they've never run the game before. Otherwise, pause it. And I'm going to copy over that to, well, I'm going to rewrite that to do comment. At the moment, the local storage format is not super efficient. It turns every single byte into a separate JSON number. And something like, actually, I wonder if I can just do it now. Is there anything built into the browser for like base64? Yeah, it sounds like we can. I mean, like, while it sounds like not every browser supports it, there's a good chance if you're supporting WebAssembly anyway, you can support that. So I might do that anyway, just right now. So, what have we got here? Here we go. Yeah. So here we're going to have our, we're meant to extract kind of like a memory region for the game state. And if we have local storage JSON, and what else are we going to have? There we go. Yeah. So we're checking that we have local storage and that we have the and we have a key in there for the state buffer we're currently looking at. We then need to let's pull that out. We then need to compare. Well, we need to first of all turn this from. We need to basically take the base 64 we just pulled out. Let's have a look at these. I don't think I've ever used these functions. So wait, what's these functions? These are some weird examples. Okay, so it creates a base 64 encodes ASCII string from a binary string. That's kind of weird. Is there anything on the... Is there anything on this type that we can use instead? Something a bit more kind of direct, because I'm not looking to go to and from strings, I'm looking to go to and from... Hey, someone's asking the same question. No, don't care about any of this. It's not a string. There we go, that's what we wanted. Ah, but I think buffers are, yeah, it's buffers Node.js things, we can't use that. Wow, okay, that's a lot of What the heck, dude? Okay, so I think I see what I'm meant to do here. I think I understand why they're doing this the way they are. Because you have to, yeah, it can only encode strings, which is a very strange thing to do. So is it, which way around is it? Is it A to B, B to A? Creates a base 64, okay, decodes ASCII to binary, okay, right. So we want to call atob on the persisted thing. That will get us a binary string, a bit weird. And then at that point we can look at the length and we can figure out what the actual size is. So, and then I guess if it's the right size, we then iterate from start to finish and take the code point of each character in it. And because it's an ASCII string, we can be pretty sure it's going to be safe. Okay, so we have a persisted thing. If persisted dot length is the same as state dot length, byte length. We'll go for byte length. They should be the same, but we'll go for that. Actually, let's go for length. Okay, so we now have a state in the WebAssembly module. We have a state from persistent storage. We've turned it into a binary string. Now we need to iterate over that string. And we need to get the code point, don't we? Yeah. And we need to put that into the state buffer we got out of the WebAssembly module. There we go. That's a bit weird, bit weird. I can kind of see where they're coming from though. Okay, that's sorted. What do we need to do next? I guess we need to do things like set up our video sort of output right here. So if we have a... Are we getting rid of the video output unless there is a... Okay, if we have a video... If we have video colors, and to do create canvas, request animation frame. Yeah, so basically this is going to include a loop here where it basically just goes round and round and round and round, round in circles. And renders to the screen. Okay. Okay, add some more in here to do video colors, combine, check. So yeah, basically we're going to have this kind of loop around, and well, it's going to create a kind of full screen canvas and then an event handler to kind of like run that. Okay, if we have a tick event. No, actually. Yeah, depending on whether the game has audio or not. And actually this can change as the game is running because the Web Audio API, you're not guaranteed an audio context at startup. Sometimes it can be a delay until you get it. You know what? I'm going to put a thing in here saying if you haven't got a video output, that functionality is to do. There we go. So yeah, that's going to complicate matters a bit, but not the end of the world, I guess. So I'm just going to flip back to my other game prototype. And this, unfortunately, is where that's where this version of it got incredibly complicated. So I'm going to try and avoid that here. So it should be as simple as that. I did actually find a bug with this when I was testing on other browsers and I haven't fixed it yet, which is that the on Edge it seemed to be like misscaling the mouse. I'm not really sure why. Didn't really spend that much time looking into it, given I was going to be rewriting it anyway. I'll get Edge open actually just to... Wow, this browser is very busy. Hang on, let me... No, I won't switch it. I'll set it up for next time. So you open Edge, it's just like a wall of buttons and icons. And I'm like, it's a web browser, dude. It's just be like an address bar, maybe a tab bar, and just a place where the internet happens. Okay. Oh yeah, I'm actually going to put something in the spec because something I was thinking about was row pitch. So why is it always reset whether this has got wrap enabled? It's so annoying. Where's the colors? The video output buffer at the bottom. The row pitch is always the maximum, always calculated using the maximum video rows. Actually, no, I'm not going to do that because that actually means you got the is always calculated using the current safe area bounded row count, column count. Okay, that's good. Can we resize this once it's created? No, we can't rename, but we can always make a new one and assign it later on. So maybe we can kind of cache that, keep a handle on what the previous width was. Oh, yeah, we have to do the same with the canvas as well. I think these are reassignable though. Yeah, you can. How weird for that to have a default of 300 by 150. How did they come up with those numbers? That's such a strange number to choose. Yeah, why would you set a default on that at all, let alone one that's that? That's such a strange choice. Okay, so yeah, so one of the complications here is that we need to kind of remember where the cursor was, and then we need to then reformat that to pass it down, because the window size could change. Let's hold off on doing that for now. And this is where our animation frame loop is going to come in. So yeah, we're going to have a enqueue animation frame function, and this is basically going to set this. And I think you do get a number in there. I think you get like a timestamp. Let me just check that. I think it might be like the number of milliseconds or something. So decimal number in milliseconds with a minimal precision of 1 millisecond. Yeah, so it might not be the number of milliseconds since the sort of game started. It looks like it's going to be like based on how long the page has been open, which, of course, if the game loads, means it might be several seconds. Sorry, I'm just sorting something out. Okay, we're good. Okay, so we start everything up, then we request animation frame. Okay, so this should, if everything works, start dumping tons to the console. And we should also be able to look at the previous timestamp. And we're going to want to clamp that because have you got time coming in? I don't know if this is a monotonic clock or not, but it's just best to be safe and assume it can go backwards. All sorts of weird things happen when time gets involved. And we're going to want to clamp this to, let's say, 10 frames a second. We do not want this, we do not want this game trying to execute time steps over, say, a tenth of a second. That get really silly. And then we're going to turn it into seconds. Oh, I know why that happens, because I changed project and back. Right. So next up we can, this is where we can start doing things like our tick progress and stuff like that. I think the best way of doing this. Remember the best way of doing this. Yes, if we have a tick progress, then we need to increment it by the delta seconds. Hang on. Actually, we should clamp that at we should clamp that at one tick. We don't want more than one tick happening per frame. That'd be kind of strange. Oh no, actually we might. Yeah, if you have a game that has like a ridiculous tick rate, you might actually want there to be more than one tick per frame. Okay, all right. Yeah, some of this code will end up running and doing nothing. Hopefully the JavaScript runtime is smart enough to go, yeah, you're pulling all this information in, but you're doing nothing with it. Okay, that's good. And then now this of course might actually break in the case that that your tick rate is really slow. So I might put a max on that so that it can run at least one tick. Okay, that should be good. Yeah, and then while the tick progress is greater than or equal to 1, and we divide that by 1,000, divided by ticks per second. Yeah, that should do. Nope, no, don't autofill that for me. Okay. And then while we're in a state where we've progressed more than one tick, we then subtract and we call the tick callback each time. Okay, so I need to have a bit of a look through the buffer documentation and make sure that I think there's quite a few that need to be set before we run tick. Yeah, so we need to set the error to 0. All right, in fact, we should probably have like a try catch on this entire thing. Yeah. So if anything goes wrong at all during a frame, we can we can put some nice errors on the screen. We don't actually put the canvas on the screen at first, do we? No, it's fine. Let's put some more stuff in here to do. Remove canvas elements. If added. And what we're going to have in here, we're going to have to do add canvas element if detached, to do hide message, do resize canvas and replace image data if size changed. Yep. So writing out myself a bit of a to-do list for next time because we're coming to the end for today. To do calculate real image size based upon safe areas, etc. Okay, I need to put a to-do in here as well to to do skip most of this if the audio system is running. Yeah, so we'll keep tracking time if so I want the gameplay to be synced to the audio whenever possible. That's just going to be really neat. But it's possible that you know, when you first start the game, people won't have access to an audio context until the user interacts with the page. And even then, the browser can actually take it away from you anytime it likes. It can go, oh, the user tabbed away from your page. Yeah, they don't want audio anymore. We've decided, we're the browser vendors, we know best. One of the nicest things actually about software rendering is that you're not using WebGL, meaning they can't take your, they can't just go, oh, you weren't using that texture, we're getting rid of it. It's actually one of the nicest things about OpenGL is the fact that it wasn't DirectX and didn't do that. Okay, so what else do we have here? What are we finishing up here? Oh yeah, we need to ooh, actually, we need to move this right to the top of it. No, we don't exit the render callback yet. Okay. The ordering here is actually getting kind of complex. So because we actually want the kind of mouse and gamepad input to be fed directly into the tick process, because you might be easy to click. It is also going to get fed into the render callback, specifically because games like FPSs and stuff like that really benefit from having that kind of real-time, you know, responsiveness above tick rate. Yeah, you need to think about that. There's going to need to be some kind of feedback so that the if you do any game logic in render, you really shouldn't be, but if you do, there is some way of measuring the passage of time. I think there is a tick progress, but you might have skipped over a tick. Okay, so resource, okay, update, pointer state. Okay, that's good. That's good. Actually, I can skip all of this until we're doing our first render. I can actually make the canvas then. Yeah, I'm going to do that actually. Yeah, why create it until you're planning to use it? Am I right? And hopefully turn those lets into consts, despite the fact I specifically wrote let for a reason. Thanks for doing that Visual Studio Code. Okay, so we need to calculate the real image size based on safe areas. So I think I've made it so that safe areas are always... Hang on. Yeah, I've made it so that it always... it calculates the safe area, well, it kind of autofills the safe area rows and columns from the maximum dimensions if they're not available. So this bit always gets kind of complicated, although once you've done it a few times, you understand the basic logic. So we have our kind of like viewport size, right? So we have the size of this window. And then we have the gameplay size, which we want to fit inside it. So the way that kind of works is you need to work out what the scale factor would be to fit it horizontally and vertically and take the smaller of the two. So that when you scale it up, you know, neither axis kind of like escapes. So let's go for row scale, which is going to be, oh, we're going to need the dimensions of the window. Let's just go back to the previous projects. I don't remember how I got that. There's actually multiple ways of getting it, and I would have done the research. Window width and height, there they are. Yeah, there they are. Yeah, there's like there's a ton of different things you can use to get the width and height of the window, and it's just a nightmare every time. Okay, so we have the height and width for the window. Go for the Y scale, which is going to be so this is the number of window pixels. The number of window pixels divided by the number of game pixels. Okay, and then we're then going to take the scale, which is going to be the smaller of the two. Okay, that's good, that's good, that's good. And what we're going to do next? We're going to, well, we then need to turn that into a real canvas width and height. Okay. I think we have the, yes, we do. Show you how this kind of works. Hang on a second. We need some ace right here to kind of like really get into the really get into the mood and really kind of like get drawn up. Okay, so this is our monitor, right? And let's say that the safe area for the game fits there. That's nice and simple, right? But the maximum drawable area kind of extends a bit either side because, you know, you've basically got a game that is slightly taller than its safe area. So at that point, yeah, we figured out the size of this. We figured out the size of this. Is there anything else we need to do really that's kind of particularly special? I don't think there is. Yeah, we just need to, hang on. Okay, so hang on. I think I know. Hang on. I just realized where the confusion is coming from. So if there's a safe area, which is, let's actually use the rectangle tool for once. I'm feeling reckless. You've got your safe area like this, right? But then, hang on. That's the maximum size. And then you've got your safe area kind of like this. Well, I've chosen some really terrible colors there, haven't I? Let's pick enough one I can actually see. Okay, so you've got your safe area as the red bit, and you've got your maximum area, which is the orange bit. You actually want the area drawn to be this bit. So when it's too tall to fit, yeah. Okay, so we can set the next video rows. And we're gonna have to check whether the scale, yeah, we do things a bit differently depending on whether we're fitting everything on the screen or not. Okay. And let's go for less, given that's the figure we're going to be using. Okay. Is there ever going to be a case? Yes, there is. Okay, there is actually going to be a case where, there's going to be a really complicated case here where, what if, say, the canvas was actually only this wide, right? So in that case, you'd be able to see some of the, should we say, the unsafe area of the display, but not all of it. Oh no, that's complicated. That's horrendous. Okay, I'm just gonna put that previous implementation back in, and how are we gonna do this? How are we going to do this? How are we going to go from this to this? So we know how big we want, the kind of scale factor. So I guess we then calculate the scale rows. So that'd be the we use the maximum rows multiplied by the scale, and do the same for the columns. And then we clamp that to the dimensions of the viewport. So okay, so we math.min that and that. So we're looking for, we want to make sure that it can't extend past the viewport. Okay, and we math.min that with the window columns. Okay, so now we have the area that actually fits on the screen. Okay. And then we divide that back down by the scale. So actually, hang on a second. What we actually want to do here is we actually want to take the min of the window rows, divide by the scale. Okay. And we want to make sure that doesn't ever exceed the maximum rows. So it's next rows, next columns. And at this point, we need to actually take video as well. At this point, we then compare them to the previous. If it's our first render, of course, we won't have any. That's fine. Huh? Oh, it's last. Oh, I'm going to call those previous instead. Because last sounds like it could, it could be, it's the one we just did, or it could mean it's the last one we're ever going to do. Okay, so at that point we can do our canvas resizing. If the canvas is null, make a canvas there. We also want to store our video rows so we don't end up doing this each time. Okay, that's good. I still do, I do still have the code that actually, oh wait, the canvas is always there. Huh, I forgot about that. I guess I'll leave that there. In fact, I'm going to make it null and then come back for it later on. And at that point, we can make it visible. Actually, we're not going to do it just yet. You know what? Put that back, I take it back. You can go there, you're fine. And we're going to calculate a new one of these. And then turn all these back into lets because it kept turning them back into consts. And oh yeah, we're also going to need to do a thing in here where we to do stop audio context. So if the game crashes, it doesn't try and so if the game crashes, it doesn't try and continue playing audio. Once again, it's turned that back into something we don't want. That's fine. All these event handlers are fine because they're not going to do anything. I'm thinking about it. There's almost no reason to actually store this animation frame. It doesn't really do anything. We're never going to queue one up and then cancel it because it's literally the last thing we do each loop. But hang on. We are going to need that if... No, we're only ever going to be doing stuff in here. Yeah. I was just thinking, maybe we're going to need that in, say if we've got another event loop going sort of like in parallel, but we're not going to do that, so that's fine. So style dot visibility equals hidden, I think. We're going to go for hidden. Let's have a look. I think I've got a canvas element in here somewhere. Yeah, visibility hidden. There we go. Okay, it's good. We've done that. We've done that. And I need to resplit this. And I need to get the web server running again. At least it should be faster now, though. Now it's zipping up correctly. Come on. Now, there's not going to be any graphics, but we can see from the sort of debugger that it's not working. Too much recursion. Okay. Yep, that's a lot of recursion. Do you have any more information on that other than it was recursion? No. I wonder what would have been recursing. I mean, like, do we even do that much in here that could be recursion? That's kind of weird, actually. Okay, let's go into the build script, and there's going to be a bit in here where it optimizes. Yeah, we can get rid of this and make it instead just use the injected JavaScript. So it's not going to be compressing the JavaScript. It's basically just going to be outputting it exactly as it's found in the file. No, wait, this only applies to like the, that's the service worker. Where's HTML minifier? Here we go, minify JavaScript, false. Minify CSS, false. I think HTML minifier, it's quite old now. I don't know if it's still getting updates. But if it internally kind of grabs Uglify.js, I might be on quite an old version of that. Man, 5 years ago. How many things are still relevant 5 years later? It's probably a much better one of these I could be using. Okay. Let's have a look at that console now. Do we have anything more useful? Get optional function. Ah, see, now we've got the names, we can actually find what the root cause is. Yep, and that's calling itself because I'm a genius. Let's try that again. Yeah, I'm just gonna check something with this. Does it, 7 dependencies. Uglify.js, but which version? Does it have a fixed version or are we getting nice up-to-date versions? Okay, the tick export is not a function. Huh. Oh. Ah, because it can be null. Okay, that's fine. What? Has this like cached something that shouldn't be there? Has the web server like lost its mind? What's going on? What? There's definitely a file there. What? Huh? Wait, hang on a second. Let me just check. Is there definitely a file there? There's definitely a file there. Stop being silly, you. There we go. Games about tick are currently unsupported, so now we need to add our tick export. Okay. Man, these are some big folders we have here. Okay. So it's actually going to be in the WebAssembly module that we're running now. So we have exports, event handlers, and this is where I was going to start implementing them. Now, I don't actually plan at this point to actually put in any headers for these. I don't think they'll be needed. Yeah, I don't think we need header files for this at all. So let's import, include export.h, and let's export tick, and that's what it's going to do for now. It doesn't like that for some reason. Oh, hang on. I didn't actually specify a return type, did I? That's the same for video and audio, because these aren't going to take any arguments. It means that if we need to change how this works later on, we can just change the buffers. We're not stuck with it's a lot easier to change the layout of the buffers than it is to change any of this. That took a while, that's weird. Okay, so that should have started the game. There's our canvas. Okay. It has actually sized it correctly. So next up, I'm just going to do some hackery in here. Perish the thought, am I right? I need to actually position it on the screen correctly. And that might be why I had the window size memory to do position canvas correctly. Okay, so the next thing I'm going to do is I'm just going to give it a background color. Let's see if that works. Okay, now we can see it. What else are we going to do? We're going to remember the last previous window rows is null, previous columns is null. good. And then we can just copy those over to there like before. I'm just going to rename these to follow a naming scheme of like using next and previous. That's good. Okay, so now we need to position and scale that correctly. So how are we going to do that? Well, we have a scale factor, don't we? In fact, you know what? You know what? You know what? I don't think I have to. I don't think I actually need to do that at all. It's already been positioned in the middle of the screen. The only thing we need to do is set the scale factor on it and set an offset, which are both things that do not change with the window size unless the window size happens to resize the canvas. Let's get rid of all of this. All of this is going to be gone. There we go. Okay, I'm going to assume if I open the previous project, I'm going to lose all my terminals again. Yeah, here it is. Yeah, I've got this sort of scaling line here. I just wanted that because the ordering of transform, I can never remember what order these go in. Video buffer. That's it. Oh, I remember this got really complicated. Yeah, in the previous version of the engine, you could have separate left, right, top, and bottom safe areas, and it got horrendously complicated because each one of them needed to be kind of like considered separately. It just became way overcomplicated. I did it again. It meant like you could have, say, a game where the left safe area was so the left safe area inset was way bigger than the right one on the right. It meant that if you fit the window, you had to kind of slide it to the side as well. It was so difficult to get right. And I'm like, no one's ever going to do that. You know, a game, your safe area tends to be centered. I wish I could remember which folder these were in. It's kind of annoying having to do this each time. Make production, because we're going to be setting some safe area insets in a minute. And let's see, let's go to hosting runtime, cd web, and run build. Should be able to get rid of that now, and we should then have a canvas that seems to fill the screen. Now at the moment, the safe area insets are they are in, I think they're in video settings, aren't they? Yeah, so if we change the safe area columns to 160, it'll rebuild everything. That's a lot faster than when we don't have any content. Oh, that went wrong. Index or size is negative or greater than the allowed amount. Okay, which line was that on? That was on this line. Well, I think that's a good place to stop because I've gone over by nearly half an hour. Hope you have a great Saturday and I'll be back doing this tomorrow. See you then.